Okay. Okay. Let us start. Nurita, it's your turn.
Yes, Professor.
Ya, halo Prof. Hsia. Terus mulai lagi.
Can I start now?
Apa ini?
Nurita, you can start now.
Yes, Professor. Is my slide can be seen clearly now? Is my slide can be seen clear now?
Yes, very clear.
How about my voice? Is okay?
Yes.
Okay. Thank you. Good evening, Dr. Cha, Dr. Net, and Dr. Majuki, and everyone. This evening, I would like to present about vitamins for microbial protein synthesis in the rumen. And I will start from the introduction. In ruminants, absorbed amino acid come from microbial protein synthesis in the rumen and from dietary amino acid sources that are undegraded in the rumen. Rumen microbial protein represent a major source of amino acid to the ruminant animal. Microbial protein contribute about 2/3 of the amino acids absorbed by ruminant. Besides nitrogen, usually in the form of the ammonia and carbon skeleton, for example, organic acids and the branch chain fatty acid, microbial protein synthesis in the rumen requires another nutrient such as sulfur and vitamins. Certain B vitamin, biotin, folic acid, niacin, thiamine, vitamin B12, pyridoxine, pantothenic acid, and para-aminobenzoic acid participate in many biochemical reactions in ruminal microbial metabolism. Then I will explain more about the influence of the vitamins in the rumen microbial protein synthesis. First, this table I would like to show. This is about the addition of the B vitamin. Especially, I would like to show the effect of the B vitamin on the microbial efficiency. Even in here, this is not significant, but we can see with the addition of the B vitamin, there is increasing of the microbial efficiency. And next, this figure, I would like to show the correlation between the level of the B vitamin complex in the rumen fluid with the level of the B vitamin in the microbial crude protein. So the relation is the increasing of the B vitamin in the rumen fluid will increase the vitamin in the microbial crude protein. And then I move to more specific B vitamin in here is the biotin. I would like to show if the different concentration of the biotin. So from diet 1, 2, 3, 4, I mentioned the concentration of the biotin concentration below. So we can see with the increasing of the biotin in the diet, it will affect on the microbial nitrogen. So we can see in here with the increasing of the biotin concentration, it will affect on the microbial nitrogen. The microbial nitrogen is also increased with the increasing of the biotin concentration. And this one is the correlation. I would like to show the correlation about the biotin and the amino acid. So biotin from the diet and synthesis from the microba will biotin is needed to or as a cofactor for the enzyme. We call it holocarboxylase synthetase. This kind of enzyme will break down the biotin into holocarboxylase, and then biotin will go to the biotin link oligopeptidase and then become the biocytin. And with the enzyme of biotinidase, it will produce the lysine. And next, I move to another kind of the vitamin B. In here, I would like to mention about the folic acid. So in the A picture is the microbial protein. From here, I would like to show if the different kind of the diet. So the line is the concentrate diet, and then the dot one is the forage diet. So we can see if we compare the forage and the concentrate diet, the microbial protein was higher in the concentrate diet comparing with the forage. But we can see in here with the addition of the folic acid, the microbial protein is less, become reduced comparing without the addition of the folic acid. So higher concentrate with the folic acid will reduce the microbial protein. And about the microbial biomass, it's also happened. We can see in here the high concentrated diet have the higher microbial biomass comparing with the high forage diet. And also the same result for the microbial biomass, the folic acid have a lowest microbial biomass comparing with the without the addition of the folic acid. From these two pictures, I got the information if the reduction of the microbial protein and microbial biomass due to the addition of the folic acid, because when the microbial synthesize the protein, they need more energy, so the vitamin will not be effective without the addition of the energy. Or we can say if the microbial protein synthesis cannot have a good result even with the addition of folic acid if there is less energy in the diet. And then for the C picture, this is the efficiency of the microbial protein comparing with the microbial mass. So from here, I would like to show after around maybe after 10 hour after meal, we can see if the addition of the high concentrated diet with the folic acid has a higher efficiency of the microbial protein synthesis comparing with the without the addition of the concentrate. And next, I move to another result of the experiment about the folic acid also. In here also mentioned about the microbial protein synthesis. So we can see in here, they compare high concentrate with the high forage. The control without the addition of folic acid and the addition of the folic acid. Both of the research show if the microbial protein synthesis with the addition of folic acid become less between the high concentrate and the high forage. As I mentioned before, the paper say it happened due to there is less energy for the microbial to synthesize the microbial protein. And then next is another result of the effect of the folic acid supplementation on the urinary excretion of purine derivative in dairy calf. In here, I would like to show with the increasing of the folic acid for the total purine derivative, we can see comparing with the control, there is an increasing of the purine derivative. So we can see in here, the medium addition of the folic acid has the higher of the total purine derivatives comparing with the high folic acid addition. It's because there is a supply of the folic acid to synthesize the microbial protein, but the energy is less. So the total microbial protein is become reduced because there is not enough energy. So next is I would like to explain a little about the purine derivative. So purine derivative excrete in the urine of the ruminant comprise allantoin, uric acid, xanthin, and hypoxanthin. It has been suggested that the urinary excretion of purine derivative could be used as an estimator of the microbial protein supplied to the animal. Unicellular organisms have been recognized as marker for ruminal microbial crude protein synthesis due to their high concentration of nucleic acid compared to the concentration in plant and mammalian cell. In ruminant, the majority of purine bases reaching the duodenum are considered to originated from rumen microbe because ruminant feedstuff have generally low purine content than the rumen microbe. So this figure, I would like to explain more about the purine, why the author would like to show the microbial protein with the purine derivative. So dietary nucleic acid, it's mean it enter the rumen and it will degrade, become the microbial nucleic acid, and then it go to the intestine. In the intestine, it will be breakdown and become the purine, and it will be absorbed, and then it will be the purine derivative. Some of the purine will be go to urine, and some a little will go to milk, saliva, and the gut. And this is the pathway of the purine catabolism. So from the AMP and the IMP, adenosine become the inosine, and then it will break down, become the hypoxanthin and xanthin, uric acid, and the last one is allantoin. The IMP in the top is the adenosine phosphate, and IMP in here is inosine 5-phosphate. So it's all come from the nucleic acid. In the duodenum, the high secretion of pancreatic nucleases hydrolyze nucleic acid into nucleotides. Its content base, pentose, phosphate. And then nucleoside is base, pentose, and free purine base. And then a great proportion of the purine base in the microbial nucleic acid are absorbed, and their derivatives are mainly excreted via the urine of the host animal. And then I move to another experiment. This experiment is about the branched volatile fatty acid and with the addition of the folic acid. So in here, they add the BCVFA and with and without the BCVFA, also with the addition of the folic acid and without the folic acid. So the result for the total purine derivative in here, first for the branched chain volatile fatty acid without the BCVFA, we can see the result of the total PD is lowest comparing with the BCVFA. And then after each of the BCVFA, without the BCVA with the addition of folic acid, and without folic acid, we can see without the addition of the folic acid, it has the lowest total PD comparing with the addition of the folic acid. And then if we compare with the addition of BCVFA without the addition of folic acid is 24.8, but after the addition of folic acid, it increased become 26. So it has a significant improvement of the total PD. It means the microbial synthesis, microbial protein synthesis is increased with the addition of BCVFA and folic acid. And next, this one I would like to explain about more about the BCVFA. So the BCVFA is come from the protein. Protein will be breakdown become the peptide. Peptide become the branched amino acid, and then branched amino acid breakdown into the branch chain volatile fatty acid. It become the carbon skeleton, and then with the enzyme we call in here glutamate dehydrogenase, and then adenosine alanine dehydrogenase. It will synthesize the microbial protein. So that is the importance of the BCVFA. And then I move to the folic acid. Why the folic acid is important? Here, folic acid in the form of the folate, it is needed to produce the methylene tetrahydroxyfolate, and then the methylene tetrahydroxyfolate become the 5-methylene tetrahydrofolate, and it is needed for the methionine synthesis. So it need to the folate is need to methionine synthesize. And next, I move to the next table about the effect of the folic acid and the sodium selenite for the urinary excretion of the purine derivative in the dairy calf. In here, first, they compare about without addition of folic acid with the addition of folic acid. We can see there is an significantly increase of the total purine derivative. And then next is about the addition of the sodium selenite. First, folic acid without folic acid and without the sodium selenite, it has the very low total of purine derivative comparing with the addition of sodium selenite. And then we move to the this part. So with the addition of folic acid, first without the addition of the sodium selenite, it's become 191, and after the addition of the sodium selenide is become 194. Even it's not big difference, but with addition of the sodium selenide, it increase a bit of the total purine derivative. And next, this one is the experiment about the effect of pantothenic acid and folic acid on ruminant excretion of the dairy bull. So the first one here, the experiment is without the addition of the pantothenic acid. We can see the result without the addition of the pantothenic acid. The number of the total purine derivatives was lowest rather than the addition of the pantothenic acid. And then if we compare each of the addition of the folic acid, there is an increasing for both addition of the folic acid. So without the addition of pantothenic acid and folic acid is 102, and it increased significantly, become 110 after the addition of folic acid. And then here, with the addition of the pantothenic acid, but without the addition of folic acid, the number of the total PD is 117, and then it increased with the addition of folic acid become 137. And then I move to another kind of the vitamin B. In here, I would like to explain about the effect of the niacin on amino acid composition of the rumen bacteria protein. Then in here, the result of the experiment show if the glutamic acid of the rumen bacterial with the increasing of the niacin, so the increasing of the glutamic acid. And then I would like to show this one. So the niacin from the tryptophan, it will be breakdown become the nicotinic acid mononucleotide. With the ATP, it will become nicotinic acid adenine dinucleotide. And then with this nicotinic acid adenine nucleotide is need for the glutamine to become the glutamic acid. This is the reason why the the bacteria protein is higher in the glutamic acid. And next, this one is the experiment about the niacin supplementation, but with the different form. So the first one in the form of the NC is niacin, and then the NCD is the niacinamide. We can see comparing with the control or without the addition of the niacin. Addition of niacin or niacinamide increase the total of the amino acid. I move to another slide. This one I would like to show about the bacterial synthesis in the form of nitrogen. Here, even the data is not significant, but I would like to show without and with addition of the niacin, there is an increasing a little bit of the bacterial synthesis. And next, the effect of the effect of the niacin or niacinamide, so different form of the vitamin B3 for the microbial protein. If we compare with the control, the increasing of the niacin or niacinamide will increase the microbial protein. And then this one is of the experiment about the addition of the nicotinic acid for especially for the total PD or total purine derivative. If we see the control, comparing with the addition of the nicotinic acid, we can see with the addition of nicotinic acid 16, 32, and 48, it will increase the total purine derivative in the urine. And another experiment also about the niacin, but this one relate with the feed. So the effect of the niacin for the microbial protein synthesis on the different substrate. Here is the corn and bromhe, and the last one is bromhe. We can see with the addition of the niacin concentration from 0 in become the 400, the protein synthesis of the um, corn and bromhe was different. So we can see if the bromhe have the lowest of the protein synthesis, and then the second highest is the corn with the bromhe, and the last one is the corn. This result is affect because of the energy on the diet. So if the diet content with the high energy or enough energy, it will cause the higher protein synthesis. And this one, this experiment about the difference of the concentrate ratio. So the low concentrate, and then this is medium concentrate, and the Hg is the high concentrate. We compare with and without addition of the nicotinic acid. So we can see in here for the microbial protein, for almost of the result, the microbial protein was increased with the increasing of the concentrate in the diet. And if we compare the addition of the nicotinic acid, we can see if the addition of nicotinic acid will increase the microbial protein synthesis. And this figure, I would like to show about the different source of the nitrogen for the microbial protein synthesis. So the first one is the amino acid, the circle one, and the triangle is using the ammonium chloride with and without niacin. The black circle is, or the black triangle is the with the addition of the niacin. So we can see from the result, with the addition of niacin for both amino acid and the ammonium chloride have a higher of the synthesis of the microbial protein, comparing only the amino acid and ammonium chloride. And this figure is about the metanethiol. So I would like to show the effect of the vitamin B6 analog. In here is the short dot is the pyridoxal phosphate, and then the long line is without the addition of the B analogs, and the medium line is the addition of the deoxypyridoxine. So in here, with the addition of the B6 analog in the form of the pyridoxal phosphate in the short dot, the short dot, oh, I'm sorry, the short line. So high high number of the metanetiol. Metanetiol is will relate with the methionine production. So this one, the mechanism of the metanetiol relate with the methionine. So the first one, the direct incorporation of the metanetiol into the methionine. The metanetiol plus the O-acyl homoserine with the enzyme cystathionine synthetase become the methionine. And then the second one pathway is the metanetiol incorporation via sulfide. The metanetiol with the enzyme methyl mercaptan oxidase become the O-acyl serine, and then it will become the homocysteine. The homocysteine will be the methionine. And then this one is the another kind of the vitamin B is riboflavin, especially the effect of the riboflavin on the urinary excretion of furin derivative in the Holstein bull. We can see in here the low, medium, and high riboflavin addition. If we see the control is 166, and then it will increase with the increasing addition of the riboflavin. And another paper I found is about the addition of the vitamin E group. So in here, the addition of vitamin E on the microbial crude protein, it seems doesn't have a significant result, but it shows a reduction of the microbial crude protein if we give the animal the vitamin E. And then this is my conclusion. Vitamin B is important for rumen microbial protein synthesis. And then the second one, the effectiveness of the vitamin B for microbial protein synthesis is related to the availability of energy. This is the end of my presentation. Thank you for listening.
Okay, thank you. Any suggestion, comments, or question for Nurita? Neil.
Thank you, Professor, and thank you, Nurita. I have question on page 30. Yes, this one. In here, why when we use the niacin supplementation with the AA amino acid, right? If we compare with the niacin supplementation with NHCl, why the AA have the good result than the NHCl?
Okay. Thank you for the question. In my understanding, when the animal, when the ruminant get the amino acid, comparing with the ammonium chloride is highest in the amino acid with niacin, is because in synthesis the in synthesis the microbial protein, we need a different kind of the amino acid. So if we add the ammonium chloride, it need more longer pathway in order to build the microbial protein synthesis. So in here, it will have a higher result in amino acid because the amino acid already how to say, like it's easier corporate rather than the ammonium chloride because it have a like a longer phase, longer pathway to build the or to make the microbial protein synthesis.
Okay, thank you. And I have another one question. I don't understand about the relationship between the vitamin or something that is have influence to influence on the urinary excretion of the PD, because you show the result about the urinary excretion of the PD a lot. So I don't understand why it have many relationship between the vitamin. Could you explain a little bit for me, please?
Actually, I would like the PD measurement is one of the measurement to know the microbial synthesis happen in the rumen. So the PD is excrete in the urine. So if as I mentioned before, actually if there is a microbial synthesis in the rumen, so it will go to the intestine, become the purin or purin derivative, and it will excrete in the form of the urine. So I would like to show the purin derivative because purin derivative, as I mentioned before, is one of the measurement for the microbial protein synthesis in the rumen. But the like how to say the mm, mm, wait. Wait, I would like to. So in here, I would like to explain if the purin derivative is the one of the estimator for the microbial protein, which is microbial protein is synthesized in the rumen. So the correlation with the vitamin, when the animal supplement with the vitamin in the rumen, the microbial protein synthesis will increase, and then the microbial protein will be breakdown into the nucleic acid, and then the nucleic acid will go to the intestine, and then in the intestine the nucleic acid will be breakdown, become the purin, and then purin become the purin derivative, and it will excrete into the urine. Because of this, actually I would like to show if there is a different or there is an increasing of the microbial protein synthesis in the rumen, but the estimator using the purin derivative or we using the I'm sorry, I forget the word, like the like the result of the breakdown. So from vitamin, we add vitamin, it will increase the microbial protein, and then the microbial protein will be breakdown, and the result is the purin derivative. In it will excrete in the urine. Could you understand my explanation?
In your result, if have the higher of the PD excretion, it mean have the good result,
Yes.
right?
Yes.
Okay. Okay, thank you.
Okay, thank you. Oh, there is a question from chat. We can say purine is important for DNA analysis. As I understand, yes, but I would like to have more detailed information about this one. I would like to find another information about this.
Thank you, Nurita, for your presentation. I also have another curiosity about the, because in your presentation you mostly focus on the folic acid and the niacin, right? Vitamin B9 and vitamin B3.
Yes.
And in case of the vitamin B, we also have the other vitamin, right? Thiamine, riboflavin, pantothenic acid, pyridoxine, and biotin, and also the vitamin B12. So how does the different other vitamin B group influence on the microbial population or like this?
Excuse me, your question is correlation. I
My,
mean the effect of the vitamin B on the microbial.
yeah, because my question is mostly when you talk about the vitamin B group, you presented about the folic acid and niacin in your presentation, right?
Yes.
So my question is whether the other vitamin B group like thiamine, riboflavin, pyridoxine, biotin groups is important or not for the other B vitamin, whether they are important or not. Because
Okay.
yeah, you
Oh,
understand my question, right?
yes. So actually another vitamin is very important in the microbial protein synthesis, like the um, mm, actually I would like to show this figure. For example, in here they mention like the vitamin B, vitamin B12, and the folate. So actually for the pathway, in the one pathway of the methionine cycle, for example, or the methionine synthesis, it will not only need one kind of the vitamin. So the vitamin is, how to say, corporate together. So like this one, the folate is needed for the become the 5,10 methyl tetrahydroxyfolate. And then another vitamin, for example, the vitamin B12 in here from the homocysteine, it will become the methionine. And another vitamin, for example, the vitamin B6 from the homocysteine, the vitamin B6 is needed for build up the cystathionine beta synthase. It's kind of the enzyme to become the cysteine. And then if you see in here, there is a choline, another vitamin B6 in the form of the betaine. It's also needed for the homocysteine become the methionine. So in my understanding, actually one kind of vitamin is cannot work. So it need kind of the corporate with the another vitamin.
Okay, thank you. And I have another curiosity in on slide 10 and 11. Can you move to slide 10 and 11?
And
Yeah, when you describe these two tables, you said because of less energy,
yes.
folic acid cannot synthesize the enough purine derivatives or what did they metabolize MP, right? Microbial protein. They
Mhm.
cannot synthesize microbial protein because of less energy. So my question is whether the energy level is same for the control and folic acid, or what is the energy level in here?
Actually, in here,
Mm,
yes.
yes.
So your question is the energy level is different between the high concentrate and the high forage, right?
No,
Or no?
no. In case of the control and folic acid, the first one in for high concentration on control and folic and high forage and for control and folic. Both of them has the same metabolic energy value, right?
Yes.
Mm. So, but when you describe this table, you said because of low energy level, when we add the folic acid, the microbial protein synthesis is less. So I was confused. Yeah. And so,
Um. Um. In my understanding, is for example the high concentrate diet. So they give the same amount of the high concentrate diet for the control, and for high concentrate diet with the addition of the folic acid. So
mm,
the number of the energy should be the same.
mm,
But if the microbe with the addition of folic acid, if they want to build the protein or they want to synthesize the protein, uh, like the wait. Uh, I would like to explain if the microbe want to wait, like the same energy amount, but if we provide the folic acid, it will have more like the substrate for the protein synthesized, but the substrate is need more energy because the number of the energy of the control and with the addition of folic acid is the same, but with the addition of folic acid there will be more substrate for the protein synthesized, but the substrate it cannot be the microbial protein because they have less in the energy, so they cannot
But
become the
the experiment didn't have a lower and higher energy treatment in the folic acid. So how can we make this kind of conclusion? If the in the experiment they have a high energy and low energy for folic acid, then you can make this kind of conclusion. Otherwise, how can we make this kind of conclusion?
Oh, yes, Professor. Maybe I have
Yes.
before I check the metabolizable energy is different in the high concentrate has the higher metabolizable energy comparing with the the high forage. Maybe I have to check again. Thank you, Professor.
Jed, can you understand my comments?
yes, yeah, I can understand. Yeah,
Yes.
as professor said, because in high concentrate in the high forest, they might have the different energy level, but in high concentrate in control and folic acid treatment, both have the same energy level, right? And in high forest in control and folic acid, they might have the same folic acid, right? That's why I also confused.
Yes, thank you. I have to check again. Thank you.
Okay.
Thank you.
Miss.
Yes. Thank you, Professor, and thank you, Nurita, for your presentation. Uh, I I I have saw for the many obstacles you have mentioned that they have mentioned about the allantoin, right? The allantoin in the urine.
Yes.
Yes, like in slide 11.
This one.
Yes, yes. Could you please a little bit explain why they have relationship about on supplementation vitamin and they will increase the alatonins, like significantly increase the alatonin?
So I would like to explain here first. This is the degradation of the nucleic acid. So the nucleic acid become the AMP, adenosine, inosine, hypoxanthine, xanthine, uric acid, and the last one is allantoin. So from here, allantoin is one of the precursor for to know the breakdown of the nucleic acid. So if we see from this figure, if we see the control, the allantoin is 57, and then it will increase with the addition of the folic acid. As I mentioned before, so allantoin is one of the result of the breakdown of the nucleic acid from the microbial protein synthesis. So if in the rumen there is a higher microbial protein synthesis due to the addition of the folic acid, it will effect on the allantoin. The allantoin will be also increased.
Okay, thank you.
As well.
Thank you, Professor, and also thank you, Nurita. Forgive me, can we see back on the slide that 10 that Chat mentioned before? Yes, I'm sorry. Actually, I also want to ask this, and Chat already asked and you answer, but from this slide, I have another opinion related with the energy. Because in this one, we don't know whether it is high or low energy, both in high concentrate and high forage. But if we look at the phi value in this case, can we say that if we provide the high energy from forage and we add the vitamin, what do you call this? Folic acid in this case, it seems like the folic acid useless. I mean, it's not give the good effect if we provide from the high energy from forage. But if the energy is come from the concentrate, maybe related with the starch, then the folic acid will be more useful. So I'm looking for the type of the energy. One is the energy from the cellulose and hemicellulose. Another part is maybe the folic acids more how to say, more working well from the concentrate is from the starch. That is.
Okay, thank you. Relate with the energy from this slide, I would like to have more paper for the information. I will find the evidence first.
And then the one question again, can the slide 9 maybe? 9?
I'm sorry.
Oh yes. Would you explain more about the figure A in this case?
Excuse me, figure A.
Yes. Will you repeat the? I I'm not really listen clearly in the figure A in this case, and the figure B. Thank you.
The figure A is about the microbial protein. So the first one, the line is the animal with the high concentrate diet, and the dot one is the animal with the high forage. So we can see from here the microbial protein result of the high forage is lowest comparing with the high concentrate diet. And then if we compare with the addition of the folic acid, we can see without the addition of folic acid, the result of the microbial protein is higher comparing with the addition of the folic acid. The same things also happen for the high forage with the addition of folic acid. I'm sorry. In here, with the addition of folic acid for the high forage, it has a bit higher after the time is maybe around 10. I'm sorry, maybe around 8. And then for the B figure is about the microbial mass. So the same, the line is for high concentrate and the dot is for the high forage. We can see if the microbial biomass, the microbial mass is higher in the high concentrate comparing with the high forage. And then with the result of the addition of the folic acid, the addition of the folic acid will reduce the biomass for the high concentrate diet. And then for the forage diet, addition of the folic acid, it seems have a bit higher result comparing without the addition of the folic acid in the forage.
So by providing folic acid, the microbial protein and microbial mass tend to be lower compared if we didn't provide any folic acid.
Yeah, from this figure, the result is it has a low.
Then there is a little bit contradictive with the next slide. Thanks. But oh no, the same line. Yes. Okay. No, thank you. Yes, thank you.
Okay, Professor Wantamas.
Yes. Can you please go to slide 7?
Excuse me, would you please repeat? Please?
My question is on slide 7.
Yes.
Yes, from this slide, when we look at only grass hair itself and also corn silage add with concentrate, right? It seem have effect on MN, not much at when we combine grass silage with wheat based or corn based concentrate. Can you explain more about the mechanism or relationship between like gas silage plus
Would you please
okay,
please repeat?
sorry.
I'm sorry.
When we look at diet 3 and 4 in this table, it seems have improved on MN in the duodenum higher than in treatment 1 and 2.
Yes.
So can you explain about this? Why when they combine together with the silage, together with the wheat base?
The question is why you compare the corn silage with grass silage with wheat and grass silage with corn. Why? Am I right? Am I right?
No. What I mean is when we look at treatment, I mean diet 3 and 4, the MN here is higher than treatment 1 and 2. So can you please explain why they are combined with gas silage with wheat base or corn base concentrate? They have increased the MN here.
Can I say if the wheat-based concentrate and the corn-based concentrate have the higher energy for the microbe? So they compare between the wheat and the corn, and then it will result the higher number of the microbial nitrogen because they have enough energy to synthesize the microbial nitrogen in here, comparing with the corn silage, because the corn silage and the concentrate, the first one, I think the corn silage is already like the breakdown with the another microbes, and then it will have a lowest energy comparing with the wheat or the corn based concentrates.
Is that okay? Because
is this nothing related with other vitamin? For example, in diet 3 and 4, they have high biotin, and then they influenced by microbial nitrogen or not?
Yeah, actually, I would like to from this paper, I would like to show if there is a different concentration of the biotin, it will affect on the microbial nitrogen. But the addition of biotin, it need like the support of the energy in order to build up the microbial nitrogen. So with enough energy, it will have more result of the microbial nitrogen.
from my point of view, sorry, I may not understand your people's discussion. My point of view, maybe the question origin is from the MN. It's nothing to do here. It's nothing to do with biotin, and the biotin will cause this kind of different in the next one or a milligram. So I really, yes, I have the same question about this, because MN, this one is nothing to do with biotin. Is that right?
No, but just want to know the reason why when we feed, when we fed like only grass hay itself or corn and silage, grass concentrate itself is not improve the microbial nitrogen at all, right? But when we fed them like grass silage or combined with base concentrate, and why they are increase the number of the level of microbial nitrogen here. So because from this table, you just show us the level of like EM, OM, or other. Different here is I can see here actually it come from CP level, right? In the 4 diet, CP level in 3 and 4 is higher than 1 and 2. So they very clear here that they influence to microbial nitrogen here. But I saw in the figure, previous figure, like it's not previous, maybe slide 19 about the pathway. So Nurita mentioned that they need many vitamin so they can improve the microbial nitrogen also. So I just point out at biotin. That's all is my question.
Nurita, can you understand?
Yeah, like in my the correlation, the addition of the biotin with the microbial nitrogen, right?
Sorry, Nurita, because I normally
So-
familiar with monogastric animal, but when we look at here, right, when you mention about nitrogen, we will look at the CP level first, right? But
Yes.
I just curious about the MN here. Even we can see here very clear they have a high CP level in diet 3 and 4.
Yes.
But from your topic today, you mentioned about vitamin related with microbial. So I just try to combine this. Like they have other reason that they can improve the microbial nitrogen in ruminant animal or not. Like for us, for monogastric, if you feed them high level of CP, high CP level, they will have a high nitrogen.
Yes.
But for ruminant, I'm not quite sure they will influenced by other microbial or not.
In my actually in my understanding, in order to build the microbial protein synthesis, they need to primary source. The first one is the nitrogen from the crude protein, and another one is the energy source. So both of these two source, it can be synthesized, become the microbial protein synthesis with the addition of vitamin. But actually the vitamin is not directly like help the microbial the protein, the nitrogen and the carbon become the amino acid or protein, but the vitamin is needed for the cofactor enzyme. So the enzyme is needed, like as I mentioned before, is needed for some part of the synthesis of the amino acid or the microbial nitrogen. As I understand, is like this.
Yes. But we think more on this table, they still have like biotin, flow, or something like this. So I just thinking that do they have a relationship between MN and biotin or CP level here?
I think I have to check again if maybe I have to find the mechanism between biotin and then the CP and then the microbial nitrogen.
When you look at like biotin, MN, right? MN, and also FOM in duodenum. Here they are increased in diet 2. After that, they are highest in the diet 2 rather than 3 and 4.
The biotin MN in the diet. Okay. Yes.
Sorry, can I make a suggestion to Nurita, Prof. Hsia?
Yes.
Yeah, Nurita, if we look at the diet 3 and 4, these two
Yes.
diets actually give a better nutrient supply to the ruminant, to the animals, compared to diet 1 and 2. Actually, for protein and also energy from, and also carbohydrate from wheat and corn based concentrate. We know that rumen microbe can synthesize actually B vitamin complex that are very important for microbial growth, supported by the availability of protein and also carbohydrate and also branch-chain fatty acid, as you explained in your some slide. I think this explain why the microbial nitrogen in this feed 3 and 4 is higher than feed 1 and 2. So supply of energy, protein, carbohydrates, and also branch-chain fatty acid for microbial synthesis in diet 3 and 4 are much more available compared to diet 1 and 2. That is the reason, I think, for the higher microbial nitrogen in diet 3 and 4. That's complex synthesis, I think. Complex nutrients are required by rumen microbe for growing.
Thank you, Professor.
Okay. I think, did you notice one thing that is interesting? The question is, the biotin in treatment 2 is higher, 4.37, compared with treatment 1. So why here the 4.37 is higher than treatment 1? Maybe this is a key point. Okay.
I will
So
check again,
because
Professor.
you know the biotin supply in the treatment 1 and 2 both is about 2.55 and 2.35. So we better to try to understand this. Okay, Nurita. Okay.
Yes, Professor.
Yes. Professor Majuki, do you have any suggestion, comments, or question? Professor Majuki, do you have any suggestion, question, and any other comments or suggestion?
No, thanks, Prof. Hsia. Sorry, I am not familiar with this Google meeting. Yeah, that's why sometimes
Okay.
communication.
Yes, and finally, it's my question, comment, and suggestion. I think
Su
everyone.
Ping not yet asked, right?
Oh yes. Subi, please ask the question. She's falling asleep.
My question is about for the literature review. Most of the situation when the vitamin B, how to say, when the treatment under the vitamin B usually have more efficiency within the high concentrate feed. So can you give some explain on it?
So the correlation. I'm sorry. Would you please repeat again?
Okay, my question is why vitamin B have more efficiency under the high concentrate treatment?
My answer will be in the high concentrate treatment. Usually, it will be high number of the energy and the high number of the concentrate, and then both of the energy and concentrate is needed for the microbial protein synthesis. And with the addition of the vitamin B, as I mentioned before, the cofactor enzyme for the microbial protein synthesis, then if they meet together, I mean the energy, protein, and the vitamin as the cofactor of the microbial protein synthesis, it will have the highest result of the microbial protein synthesis.
Zhu, can you understand?
But my question is usually in a experiment, they will usually use the same energy on the basis. So I don't think the energy is the key point on it.
Excuse me, the energy for
Because for your explanation, said that the vitamin B, if we have to use the vitamin B to synthesize the protein, they need more energy to do it. But because of the less of the energy, so they cannot have more benefit on it. But my question is, usually for the experiment, we will provide the same energy for each treatment. So I don't think the energy is the key point on it.
or maybe I have to check again. Like this example from this experiment, they may have the different level of energy, but I will check again another paper which have a same level of energy. How does it affect on the microbial protein synthesis?
Thank you. And I have the second question. It's about if the vitamin B really have the benefit on the microbial synthesis. So what can we do in the future?
I think we have to, in my opinion, we have to supply supply the balance of the energy, the protein, and then the vitamin B. So it will have the good result for the microbial protein synthesis. And then not only the microbial protein synthesis, because the microbial protein synthesis is needed for the ruminant to fulfill the protein requirement. So it should we have to provide the balance of the energy, protein, vitamins to see the result of the like the performance of the animal related with the protein accumulation. Could you understand my? I'm sorry, my English is not really good.
It's okay. I just wondering, the vitamin B can increase the milk content of the protein, just like that.
Maybe it's a key point. And it's my, Susu, are you finished?
Your turn.
Are you finished?
Yes.
Yes? Okay. The key point is, Nurita, you have to be really give the whole picture. Okay, until now, you still cannot give us the whole picture about the vitamin relate with the luminous condition. If you can give us the whole picture, for example, some students ask about vitamin B1, B2, or something else, and then you give the whole picture about this kind of lumen content. What will be help the lumen fermentation better, and then you will find this is the future. Just as Susu said, what is the future? Okay, if you do not combine all this kind of information together, and you will get trouble, because if you're doing some kind of experiment, you are only concentrate on the folic or on the niacin or on the nucleic acid or on the pantothenic acid. That is very dangerous. Okay, so we want to know what is the major things cause this kind of variation. And another important thing is, just like Eswa said, because during the fermentation, you will produce a lot of vitamin. So what kind of situations you will produce? What kind of amino acid? This is a very important thing. If we still cannot understand the whole picture, and so we cannot make decisions, say which kind of, we are almost near we will start experiment. We have to know the whole picture. Okay, and could you show your the final page on the conclusion?
This one.
You said vitamin B is important for lumen microbial protein synthesis. But did you notice you said folic acid is not important? So this will be a little bit of conflict. So the best way is read more literature review and make the whole picture. Because at the moment you really need the whole picture. If you know not the whole picture, we will be very confused about which vitamin will be the most important in the protein synthesis. Okay, because your master degree is working on the bypass protein, and so we try to relate this kind of protein with vitamin group. So please try to make it a whole picture. Okay, not just part of them. Try to make the whole picture. It's not easy, but you have to read all the papers. Please, okay, read more papers. Another thing I have to suggest to you, because your speaking is too fast, and then you are easy to make a mistake. Okay, so you can say, you always say sorry. So please don't speak too fast. Speak slowly.
Yes, Professor.
That is more important for you, and also important for everyone, including myself. So we better to encourage ourselves. Two things to all my own students. Sorry, the other student, please forgive me. all my own students, please read more, read more, read more. Okay. Just the last week, I went to the senior high school in Tainan city. I said, if you want to never give up, the most important thing is please read more. Okay. It's not only for my own student. I hope all my, it's not only for the high school student, but also for my own student. Please read more. If you can read more, you can make the whole picture. Sorry, says that my supervisor also mentioned to us, please make the whole picture. Once you have a whole picture, then you can make it easy to make a decision. Say which kind of things is most important for me to do the experiment. Okay. This is a very important things. If I continue, and then I think everyone will complain to me, say it's already 9:30, 34. So I better to stop now. Okay. So everyone, please read more and then make some kind of whole picture. Then your future is more easy to do anything, to do any kind of things. Thank you for everyone. Thank you for Nurita's presentation, and hope next time we can everyone try to make the whole picture. Okay.
But can I make a suggestion to Nurita, Prof? Hsia?
Yes, please.
Is that your research for PhD program, Nurita, regarding vitamin?
Yes, Professor. Yes.
Oh, then you have very complex topics, I think, because as you mentioned, vitamins cannot stand by itself. They have to interact with other vitamin, because the vitamin is mostly involved in biochemical processes as an enzyme or coenzyme. That's why Prof. Hsia suggests you have to read more paper to have a comprehensive understanding about the role of vitamin. Again, vitamin cannot stand by itself in the process of biochemical. I think that's Prof. Hsia.
Yes. Thank you.
Okay.
Thank you for your suggestion. So maybe the Professor Majuki said it is right. Comprehensive. This is a good word. Comprehensive. Read more papers. Okay.
Yes, Professor. Thank you.
Yes. Okay. Anyone want to make some kind of final conclusion? If not, then we finish today's seminar. Thank you for Nurita, and thank you for everyone, and thank you for everyone's question. Thank you.
Yeah. Okay.
Good night. Thank you.
Yeah.
Good night. Thank you.
Good night.
Thank you, everyone. See you.
Thank you.
夏博，
是
因为确的本来要4道，还是你要改明天比较好？今天
没关系，我听他的。
你要听他的吗？
对，
那我把学生扣回来哦。
可以啊。
好，等一下。Chat, did you tell them that you have to rehearsal it? Yes?
Okay. No, I didn't tell. I just texting. Okay. I text in the group.
Sorry, I don't know how to leave the meetings actually.
Oh, okay. You just key the telephone, and then you will off. Did you see the telephone underneath?
Which one? No.
I have a red color.
Okay, I will try.
It's a right color.
Yeah.